Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Seth's brother Joel. We're here to hopefully show you how to approach SAT math questions, maybe even all math questions. Here we have a question that from an older SAT, but it feels like it could be on the post 2016 SAT. So let's just get right to it. Why don't you try it? Pause, come back, and we'll go over it. Again, we'll really focus more on the approach than anything. Seth, this is obviously geometry. You want to give it a
Yeah.
shot? Go ahead.
Okay. When I first saw the problem, uh, I saw that they want you to find the angle at B, and you're given information about angles at A and about C. So the first thing I did was think about how to calculate the angle with the triangle with this little triangle ACB. This angle is the supplement of the angle of 85 degrees that we know. Okay. Now, I also know that if I know y and I know this angle, I could use the fact that that y plus the angle C of the little triangle, which is 180 minus 85, plus x, the unknown angle, equals, well, every triangle in the plane has a property that the sum of the angles is 180 degrees. Basic fact in geometry that this is testing you for knowing. And we know y, right? Y is 40. Or we might write the 40 here. We have to do the arithmetic, so we might as well. Okay, we could either do the arithmetic here, but now that I actually wrote, come on, I want to scribble.
Yeah,
Now that I,
froze a little.
uh,
You have to
I,
excuse. Sometimes Zyboard freezes.
okay, now that I wrote the equation, I could now make the arithmetic easier by using laws of algebra.
Okay.
So the come on, ah, y is 40. Let's make that a 40.
And don't forget, everyone will have a calculator.
No, okay, no.
But
Cancel the 180s.
ooh, that's smart.
Bring the 85 onto the right.
Okay.
Bring the 40 onto the right. And the answer is 85 minus 40, which is easy arithmetic because it's easy to subtract 4 from 8.
Right.
So we get 45 is the answer.
Right.
And we see it's one of the choices.
Right. So essentially, that was really smart on the algebra side. So you did 40. Essentially, became 40 minus 85
Yeah. So in terms of approach,
equals.
I had in my mind that I might want to subtract 85 from 180, and I was about to do it, but then because I wanted to explain to you, my audience, my thinking, I wrote the algebra. I expressed what I was saying in words, and which I thought in my mind. I wrote it out in algebra, and then I noticed I could make the arithmetic easier by using principles of algebra.
Mm.
So I wouldn't have thought of this without having written the mathematical facts in algebra, as opposed to thinking of them in terms of how I could calculate an unknown from knowns using arithmetic.
Let me be honest. I didn't follow that, but that's okay. That's okay. That's okay. That's okay. But it
Yeah,
was
no,
really smart.
plan, the original plan that formed in my mind to solve this problem was to, I'll show you the original plan.
I mean, are you talking about on the geometry side or on the algebra
On the
side?
mind of Seth's side,
No, no, no. But geometry or algebra?
geometry and
Okay,
arithmetic.
geometry and arithmetic. Go ahead.
Okay, here's what I thought.
Go ahead.
This is 85. So this is 180 minus 85.
Right.
And I calculate that to be 95. So I'd write a 95 here.
Right.
And then I know, given that y is 40.
Yep.
And then I would take 95 plus 40.
Right.
And subtract.
Well, you can add the 135.
That. Yeah, and then subtract it from 180 to get the answer.
Yeah, but at this point, you could say.
No, I'm sorry. What I'm telling you is that the plan that my mind first came up with
got it.
Was this one.
Got it.
And then when I explained it to our audience, I added the written algebra here.
Right.
Purpose of explaining it. And after I wrote it down, I noticed that I could make the arithmetic simpler.
Okay. So what that all that simply means is that if you were solving the problem yourself, you never would have written this.
Well, that's possible.
Because you wouldn't. If you do it yourself, you're not going to be explaining it to the audience. You're just going to.
That's right. Yeah. I think you're right. Yeah.
So this is actually very artificial.
Well, it perhaps it's a lesson that perhaps when you have an approach that involves only arithmetic, maybe it's better to delay doing the arithmetic,
right,
and then express the facts in algebra.
Yeah, well, yeah. I mean, boy, absolutely. They really see that when you have factors of things. When you have everything multiplied by something else, it's so much better to leave it all as factors.
Yes.
So that at the end, when you're dividing everything, you just simplify all the factors, and then you get the answer a lot faster.
Yeah. But one of the lessons that they taught in my college courses, in engineering and science, was that when you solved an equation and arithmetic operations occur,
right?
The lesson was, and you're doing it on paper,
right?
To delay doing the arithmetic
absolutely
until the very end. Get an expression. Express if the answer is a number,
right?
Write out an expression for that number in arithmetic.
Absolutely.
And when that's all finished, you then use whatever means for calculating you have,
right,
to reduce it to a number.
Yeah, that is so unbelievably important, because, for example, very, very quickly, if you're going to do an area question, area is 1/2 base times height, and the base is
for a triangle.
7. Yeah, for a triangle, right? Yeah, for a triangle, right? Base, height, doesn't matter, and height is 3. You don't. What you do is you write it out like this: 7 times 3, and you leave it like that until the very end, and then you multiply. That's so important. Why is it also so important? Because you can quickly see if you're making a mistake.
Mm.
Right? You can look at it and you can say, "Oh, I'm making a mistake." Plus, if the teachers are grading it, they would see that, "Oh, at least the person knows what they're doing." If you multiply it wrong, it's not that big of a deal. Oh, it's so important to leave everything as factors and only do the arithmetic at the end. Please, please get in that habit. Unfortunately, in fifth grade, they don't teach that. In fifth grade, they're so into calculating, getting the answer to multiply two things. Like everyone gets in the bad habit of, "Oh, I have to calculate everything when I see it." Oh God, no. No. Look, take all the way to college.
Well, do they? They don't. Do they teach any algebra in fifth grade with that is algebra with variables?
They don't teach any algebra in fifth grade. But in fifth grade, you're so into calculating things like 3 times 9, right? Oh my God, you got to get the answers. 27.
But there's also problem solving.
Yeah,
word problems.
Yeah, or it brings you a bad habit because you're so in the habit of getting answers. But once you start doing problems, you leave the arithmetic at the end. Oh, it got so important to do that. So, thanks, Seth, for discussing this. I have some pretty strong thoughts about this problem. This problem, see, Seth, this problem can be done if you recognize the geometric relation of this problem. You can do this problem virtually instantly using what's known as the triangle exterior angle theorem, or the exterior angle triangle theorem. What's it? Triangle? It's the exterior angle theorem for a triangle. There's this theorem that says that if you're lucky enough to recognize this, the exterior of an angle in a triangle is equal to the sum of the two remote interior angles. And because y is 40, x plus 40, you immediately see that it's 45. It's called the exterior angle triangle.
Oh, wow, I forgot that.
Yeah, you forgot that.
Oh, yeah, right.
And by the way, did you notice that Seth, in his brilliance, he got this, and then notice I simplified it this way. This is the algebraic explanation. Oops, sorry about that.
Yeah.
This is the algebraic explanation of the exterior triangle angle theorem, or whatever you call it, because this is essentially it, right? You have 40 plus x is equal to 85, which is essentially what happens when you cross off the 81.
Yeah. Oh, yeah. Okay. Right? Good. Yeah.
So,
of course. Nice. Yeah. So
now.
So that helps. I don't know. So maybe if you study for the SAT, it'd be a good idea to review theorems in geometry like that. Frankly, if it came to my you remembered and identified a very useful theorem,
right? So
which I didn't.
Okay, now for my big point. I am not a fan of this theorem because it sort of teaches memorizing things as opposed to really understanding what's going on.
Yeah.
I don't like this theorem. In fact, it's really an optional theorem. You don't have to know this to do this problem. In fact, sometimes this helps. You can have a complicated triangle problem, and if you do it the way Seth, I would do it, you may end up with a 2-equation, 2 unknown problem, and it'll be harder to solve.
Yeah.
So sometimes this really, really helps, but I am such a not fan of this theorem because why memorize something if you don't really have to? You just do exactly what Seth said, which is you make these guys supplementary, which you have to know. You have to know the two angles that make up a line are supplementary. You have to know that. And you also have to know that the 3 angles in a triangle add up to 180. Those are things you absolutely have to know. This you really don't have to know. Yeah. But for the people who know it now. I'm not sure if I said before, but in May of 2016, I personally took the SAT as an adult, and I studied for it, and I made a cheat sheet of everything I needed to know for the SAT. And I just looking at my cheat sheet before we started, I listed everything. What I did is I studied on Khan, like we're going to do at some point on this video program, this video stuff. And I wrote down everything I needed to know for the SAT. And the way I did this is I did all the problems and I wrote down everything I needed to know. Guess what?
Yeah.
The triangle exterior angle theorem is not on this list.
Oh.
Which means that either I never really paid my it wasn't something that was obviously needed to be known for the SAT. Maybe because I hate it so much and I resent it so much. It's ridiculous wasting time to teach this thing because you should just do it from fundamental principles. So, as you can see, I don't really like the triangle exterior, but you should be aware of it. If you know, almost everyone's exposed to it. But yes, you forgot it. Right?
Yeah.
You forgot it.
Right.
Yeah. Because because it's optional. It's an optional theorem. So when you learn it in school, like it's an optional thing.
Yeah.
You know, don't make.
Yeah.
And it's better to make that more obvious. I wish teachers would say, "Hey, we're going to do something that's optional," so that they understand that you don't really need it. You can do it through other ways.
Yeah.
Why clog the brain up with extra theorems?
But it's fun.
Fun. What's so fun about
it? It's more fun. There's more.
That's a pickle?
That's a pickle, yeah. Puff on my pickle.
You're eating a pickle at 11:24 in the morning?
Yeah.
Okay. I don't know if it's fun, but I just wish they would make a bigger point that it's an optional theorem, as opposed to the other ones that really aren't optional.
Yeah. Well, mathematicians don't care.
What do you mean?
They don't think. They say, I don't know if they say it's optional. They sometimes say things are optional, but yeah. What they'll do is say that certain theorems will not be used in subsequent applications in a paper or textbook. Yeah.
Well, what is it called? It's called the triangle exterior angle theorem, I think.
Yeah. Well, there's a more interesting theorem about the exterior angles, which implies this basic theorem we cited, that the sum of the interior angles is 180.
Right.
This exterior angle theorem says that with any polygon, the sum of it then extends each edge,
right,
in the same sense, through a vertex,
right,
and that generates for p vertex polygons, you get p exterior angles.
That's right.
The sum of those exterior angles is a full circle.
That's right.
And that can be used to calculate what the sum of the interior angles are. This turns out the sum of the interior angles depends on the number of vertices.
Right.
Yeah.
I blew this one.
They used to call this, or some people call this, in the days of Papert at MIT in the 60s. They used to call this the turtle theorem, the total turtle theorem.
Oh yeah?
Yeah, and it goes like this. Imagine that there is a turtle that walks along the edges of the triangle, and when the turtle gets to a vertex, she rotates, in order to change direction to proceed along the next edge.
Right, so that's...
And how much she rotates at each vertex is equal to the exterior angle. But when she eventually rotates one full turn.
Oh, right.
And one full turn is a full circle, 360 degrees.
Right.
And that is the turtle argument that demonstrates that the sum of the interior angles for any polygon is 360 degrees.
Interesting, right?
And it even applies to non-convex polygons, provided that you track the the sign, not the
algebraic sign,
whether an angle is positive or negative, whether an angle of turn is positive, which is counterclockwise, or negative, which is clockwise.
Right. The sum of exterior angles.
Yeah.
Sum of exterior angles in a polygon. And it could be, right, equals 360. Now I'm looking at my cheat sheet of the SAT that I made in 2016, and that is not on the list. That is not on the list. So either I missed that, or it wasn't on the, it's not on the list. Of things.
So what?
Oh, wait, no, it is. It is on the list. Wait. I have something called polygons. Each, okay, on my list is the sum of the internal angles of a polygon is 180 times n minus 2.
Right.
And then each internal angle you divide by the n if they're equal. But nowhere on here is the list, does it say the sum of the exterior angles? So either I missed it on my cheat sheet, or you didn't have to know it, but you should know it.
Yeah. Now, so remind me, what sources did you scan to form the cheat sheet?
All con questions.
Oh, con questions.
All con questions, of which I'm hoping you and I are going to do 600 of them. And the 8 or 10, I forgot how many there are, SAT practice tests. Official practice tests.
Oh.
I did every single one. And I made sure that everything that was on these two sources, all the con practice, which is sanctioned by the SAT, which is when you go on the SAT website, say, please do the con practice. And all of the practice tests. I did every question, and I said, is this principle on the cheat sheet? And if not, I added it. So either I missed it, but just politely, how many, it's possible I missed. Of course I missed some stuff. Yeah. Or you never really had to know that. I don't know which one. Yeah. But I think on the ACT has more geometry than the SAT. So if you don't need to know this for the SAT, you almost certainly have to know this for the SAT, for the ACT.
Yeah.
Which we're not talking about. But yeah. Okay, everyone. Well, we certainly, as we usually do things, we overdid this a little. But that's okay. People have the privilege of just stopping the video whenever they feel like. Okay, everyone. So tomorrow's Thursday. Let's hope we could do Throwback Thursday. That'd be nice. Okay, everyone. Have a please give us your likes, dislikes, your thoughts, likes, dislikes. Please post your comments on our YouTube videos or email us at satmathquestionoftheday@gmail.com. And if you have any SAT math questions you'd like us to look at, then email them to us at satmathquestionoftheday@gmail.com. It's been a long day. Okay, everyone. Have a great day. Bye.
Okay, bye.
Bye-bye.